All right, so down at the bottom here, we're going to have time, and that will be in seconds. And then here we have distance in meters. And anytime we have kind of a problem like this, we're going to have to set up the scale. In order to set up the scale, we looked at the lowest, we look at the highest value, and on our x, we need to go from 0 to 10. So it looks like we can go maybe every 2 spots. Yeah, I think that's going to be lots of space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. All right. And then from here, we're going to do distance. So lowest is 0, highest is 70. Maybe going up by 5s. So 5, 10, 15, 20, 30, 40, 50, 60, 70. Looks good. All right, so let's go plot these points. Again, please push pause if I'm going too fast. This is a video, I'm only allowed a certain amount of time in these videos, so make sure you're pausing it and everyone's writing everything down. We're going to plot the points after we do a title. So distance versus time. Let's plot the points. So the points at 0, 0, 2, 10, 3, 20, 5, 30, 6, 40, 7, 50, 9, 60, and 10, 70. All right. Okay, so there we are. We're also going to plot our mean data point. So our mean data point is this one at 5 1/4. So that'd be like 5 1/2, 5 1/4, and 35. So right here. So we know our line of best fit has to go through that point. Okay, so line of best fit's going through that point, and as many points as possible. That looks great. It is starting at the 0, 0. We have 1, 2 above and about 2 below, so that looks like a great line of best fit. This is, again, our average point, or our mean data point. Gives us a good direction as to where our line is going through. Right, so press pause, make sure you have all that information down, and we are going to find the equation of the line of best fit. Okay, so first of all, we need to find a slope. We need a point and our equation. Remember, our equation is y minus y1 is equal to mx minus x1. All right, so our mean point is a point that we have. Well, let's go find the slope. So the slope we can find by taking any 2 points that are on our line of best fit and find the slope. Okay, so I'm going to grab this point, looks like that's on my line of best fit, and the mean data point is 2, and same with this point. So any 2 points. I think I'm going to grab this one, 3 and 20 and 6 and 40, and find my slope. So the slope is y2 minus y1 over x2 minus x1, and I picked the points 3 and 20 and 6 and 40. Right, again, any 2 points that are on your line. Your line might look a little different from my line. That's okay, it just depends on how you graphed it or how you drew it. Just pick any 2 points. You can even use your mean data point. We might get something like of a little bit different slope, but that's okay. All right, so here I'm going to do y2, which is 40 minus 20. 40 minus 20 divided by 6 minus 3. That gives us 20 over 3. Right, there's my slope. I'm going to pick the point 320 to use and plot it into the equation. So we have y minus, this is x, this is y, 20 is equal to 20 over 3, x minus, and then my x point is 3. Right, it's not going to be the prettiest of equations, but again, this is an equation of a line that we just drew. Like, it's not something that's like made perfect. Right, let's bring the 20 over the other side. So we've got 20 over 3, x minus 3 plus 20. And now we're going to use that rainbow property and distribute the 20 over 3 times x. 20 over 3 times negative 3. You're going to cancel with those negative 3's. You could do this on your calculator. 20 divided by 3 times negative 3. That's just going to give us negative 20 plus 20. And look at that, the 20 and the 20 eliminate, and we get 20 divided by 3x. Right, we're going to use this equation to make some predictions, and from the graph as well as from our equation. So at the time 55, so 55 meters. So at what time would it cover 55 meters? Again, please press pause, get that down, and then move on to the next step. All right, so at 55 meters, so 55, we have to go up to the graph and find 55, and then go over to our line of best fit and down. At 55, it looks like it's going to take 8 seconds. From the equation, let's go try it. Our equation is y is equal to 20 over 3x. 55, that's on the y. So 55 goes in for your y. 55 meters, that's a y, that's not a time. Time is x. And then we have x. You could also use t if you wanted, and d. But we're just going to use x and y. Now we have to solve for x. That means we're going to multiply this side by 3 and this side by 3. The 3's reduce. We get 55 times 3, which is 165, and equals 20x. That means we're going to divide by 20, and we get x is equal to 8.25. That's what we get. So from the graph, it's more of an approximate, and from the equation, we get an exact value. It should be 8.25 seconds. And since we're looking at this inside the data points, like we found this information at 8, so it's inside the data points, that's called interpolation. We use interpolation because it's inside the data. Again, press pause, rewind, fast forward. If you need to relook at this, please do. Right, at 12 seconds, let's go up to our graph. 12 seconds, where's 12 seconds? Oh, it's past the graph, it's over here, it's 12, it's way over here. Okay, so for 12 seconds, let's see, it looks like we're gonna have to extend the line, and at 12 would be like probably around, would you say like maybe 85? Looks like 85. That's 70, that's 75, 80, 85. It looks like 85. Again, a huge approximation, right? Let's go check and see if it's really 85 from the equation. So our equation is 20 divided by 3x, and 80, we're going to put 12 in for, 12 is for seconds, that's x. So we're going to put 12 in for x, because x is time, and time is in seconds, and seconds is 12. Right. And then when we do 20 times 12 divided by 3, we actually get 80. It's 80 seconds. So that's what we get from the graph. And here, since we had to go out of the data, the 12 is not in here. We had to go outside, exit, extrapolation, because we had to exit our data points. So that means it's going to be outside. All right. Again, please press pause at any time to see if you need to go back, reverse, pause at any time during the video. Right, lastly, using a technology, we would have done some of this yesterday, looking at a line of best fit. So to maximize, we find what we call the mean data point. Here we're looking to if it's positive or negative. So just looking at this graph here, it looks like it's going up by positive. And when you get into more higher level, you're going to see an R model. So an R model, or an R squared value, goes from 0 to 1. And that tells us if it's a strong relationship or not. So a stronger relationship, the higher the value to 1. The weaker the relationship, we would get like near a 0. This, we can see we have an R squared value of 0.99. So this is a very strong relationship. Meanwhile, here we see the points are scattered everywhere, and we have a very low R squared value. So this is going to be a weak relationship. So our relationship goes between 0, -1, and +1. This would be your strong positive. This would be your strong negative. This right here would be no correlation. And then we have the weak is kind of between like this space and this space. You would get your weak positive and negative, depending on if you're negative or a positive line, and then anything like above like negative 0.5 or 0. Like over here is more strong, right? So that's kind of how it is. Like this is anywhere in here is weak. If it's 0, it's no correlation. You can't really tell. Like that's almost like no correlation, right? The points are everywhere. It's saying that it's a negative, but holy moly, does that look really, really weak. More like no correlation. Strong, you get like points are almost connected. So that's called an R-squared value. So if you do see that, that's what it's talking about, that the points are really, really, if you're getting close to 1, you're strong. If you're -1, you're strong. Anywhere in between there could be weak, or like you can say like medium. If it's like 0.5, it's not weak, it's not strong, kind of like medium. All right. If you have any questions, please let me know. Check out the OneNote and your worksheets for the homework. All right, take care.